All right, let's go ahead and get started. I do want to welcome you to this worksheet. This is stoichiometric calculations. We're going to divide this one into two parts. That will allow us to slow down just a little bit and understand this concept a little bit better. We're going to need a periodic table and a calculator for this one, so if you don't have those, pause the video and we'll get started. So here we go. What do we mean by stoichiometry? Stoichiometry means taking a balanced reaction like the one we see here and using it to determine an unknown from some known value. So let's take a look at the problem. It says how many moles of potassium chlorate must decompose in order to produce 12 moles of oxygen gas. And so they're telling us that the 2 moles of potassium chlorate, that's solid, will decompose into 2 moles of potassium chloride and 3 moles of oxygen gas. So it's a 2 to 2 to 3 mole to mole to mole relationship. Now, how do I begin the process? Well, the first thing I'm going to do is I'm going to look for the number. In this case, it's 12 moles of oxygen gas. I'm going to circle that. That tells me where to start. And then I'm going to look to see what I'm being asked. In this case, I'm being asked for moles of potassium chlorate. So I start with what I've circled and I simply write that down. So in this case, it's 12 moles of oxygen gas. So I'll write that down. And I'm going to put that over 1. That 1 simply holds the numerator and the denominator in place. And we're going to multiply then. So now what I'm going to do is whatever unit's in the upper left goes into the lower right. So moles of oxygen gas go in the lower right. So that'll happen every time. Whatever unit's in the upper left goes into the lower right every single time. Now we're being asked here for moles of potassium chlorate. So we're going to put moles of KClO3 right here, moles of potassium chlorate. Well, what is that ratio? Well, the balanced reaction tells me that 2 moles of potassium chlorate produces 3 moles of oxygen gas. So it's a 2 to 3 mole to mole relationship. Now, this unit and this unit are going to cancel, and I'm going to be left with moles of potassium chlorate. Is that what I'm looking for? Well, look to see what you've underlined. Yes, moles of potassium chlorate is what we're looking for, and so it's just a matter of multiplying 12 times 2, that's 24, divided by 3, that's 8, so that'll be 8 moles of KClO3. So what have we said here? We've said that 12 moles of oxygen are being produced from 8 moles of potassium chlorate. And we're done with number 1. Let's look at number 2. Number 2 says how many grams of KClO3 are required to produce 9.20 moles of potassium chloride. And they've given me the balanced reaction. Again, it's 2 to 2 to 3, mole to mole to mole. Let's circle what I've been given. In this case, it's this right here. It's 9.20 moles of potassium chloride. And this time I'm looking for grams of potassium chlorate. So what I'm going to do is I'm going to start with what I've circled, which is the 9.20, and that's moles of potassium chloride. So KCl is what I'll start with. I'll put that over 1. That holds the numerator in place, and then I'll multiply. Remember, whatever unit goes in the upper left goes into the lower right. So that's moles of KCl in the lower right. What goes in the upper left or the upper right? Well, in this case, I'm looking for grams of KClO3. Unfortunately, I can't go from moles of KCl to grams of something else. So I have to do what's called a mole-to-mole bridge. I'm going to bridge from KCl to KClO3. So we have moles of potassium chlorate up here. Now, what is that relationship? The balanced reaction tells me that 2 moles of potassium chlorate produce 2 moles of potassium chloride. So it's a 2 to 2 ratio, just like that. Now what I'm going to do is cancel this unit with this unit. Now you may ask, well, isn't this an unnecessary step since 2 cancels with 2 anyway? Well, mathematically it may be inconsequential, but from the standpoint of the procedure, you have to do it the same way every single time, even if they do cancel out. So we'll do it. Times whatever unit's in the upper left goes into the lower right. So in this case, it's moles of KClO3. So we'll put KClO3 right there. Now, what are we looking for? We're looking for grams of KClO3, so I'll put that on top. So grams of potassium chlorate go on top. Now, how many grams does 1 mole weigh? Well, I'll just go to my periodic table and add up potassium plus chlorine plus 3 oxygens, and the value that I get is 122.55 grams per mole. Check me on that. This unit and this unit will cancel and leave me with grams of KClO3. That's what I'm looking for. So now it's just a question of getting the calculator out and multiplying 9.20 by 122.5, and what I get is this number. Actually, I get 1127.46 on my calculator, but I only want 3 significant digits because I only have 3 significant digits in the 9.20. So let me revise that answer to 1130. Don't put a decimal after the 0 because that would render the 0 significant. I don't want it to be significant. The unit then would be grams of KClO3, potassium chlorate, and that would finish the second one. Okay, let's go to number 3. Number 3 says this. Number 3 says, how many moles of water are produced from 63 grams of oxygen gas? This one is going to require that we balance the reaction. If you need practice balancing, go back and watch that video. This one balances to 2, 1, 2, just like that. So 2 moles of hydrogen gas plus 1 mole of oxygen yield 2 moles of water. So I'm going to circle what I've been given, 63 grams of oxygen, and underline what I'm looking for. I'm looking for moles of water. And now what I'm going to do is start with what I've circled. So we've got 63 grams of oxygen gas. Remember, I'm going to put that over 1 just like that. Then what I'm going to do is whatever unit's in the upper left goes in the lower right. Grams of oxygen gas. Just a quick tip. That is, this is a mole to mole to mole relationship. So anytime you have grams, you need to change it to moles immediately, right? Before you do anything else. So we're going to put moles of O2 up here. So moles of oxygen gas here. And I'll ask the question, how many grams does 1 mole weigh? Well, it's 32.00, 16 twice. Now this unit and this unit will cancel away, and I'm left with moles of oxygen gas. I'm going to need a mole to mole bridge now because of the fact that I've got to get to water, right? So we have moles of oxygen gas, whatever's in the upper left goes into the lower right, and into the lower right. And what I put into the upper right is what I'm looking for, which is moles of H2O. Now, what is the relationship between H2O and O2 from the balanced reaction? Well, as it turns out, 1 mole of oxygen gas produces 2 moles of water. 1 mole of oxygen gas produces 2 moles of water. I get that from the balanced reaction. Now, this and this will cancel, and notice I'm left with moles of water. That's what I was looking for. So we'll get the calculator out and say 63 times 2, hit the equal button and divide by 32. And when I do that, I get this number, 3.9375. Let's talk about significant digits. I can only have 2 this time. The 3 will not kick this 9 up. So I'm simply going to say 3.9, and that's moles of H2O. And that'll do it for me for this third problem, okay? Let's go to number 4. Number 4 says, how many grams of hydrogen gas would be needed to form 14 grams of water? So balancing this reaction again is 2, 1, 2, just like that. That balances the reaction for me. And now what I'm going to do is start my routine. I'm going to look for the number, circle it, 14 grams of water. Look for what I'm looking for, grams of hydrogen gas. So I'm going to underline that. And now I begin. I take what I know, which is the 14.0, and that's grams of H2O, just like that. And I'm going to put that over 1 times whatever unit was on the upper left goes into the lower right. So I have grams of, whoops, let's make that H2O. So we've got grams of water on bottom. Remember that if I have grams, I need to get out of there as soon as possible, get to moles. So 1 mole weighs 18.02 grams. Just added up 2 hydrogens and 1 oxygen and got 18.02. So now grams of hot water and grams of water are going to cancel away, and I'm left with moles of water. Now I'm going to need a mole to mole bridge. Moles of water on top, moles of water on bottom, just like that. Now I need to go to hydrogen, right? Because it's asking me for grams of hydrogen gas. So I'm going to say moles of H2 right there. Now what's the relationship? Well, here it is. 2 moles of hydrogen gas produce 2 moles of H2O. Not a wasted step, even though the 2 and the 2 are going to cancel. Have to do it, right? So now this unit and this unit are going to cancel away, and I'm left with moles of H2. Not quite done yet. I need one more step, because 1 mole of hydrogen gas is going to weigh 2.02, that's just 1.01 twice, grams of H2. That's what I'm looking for. I'm looking for grams of hydrogen gas, so it's time for the calculator. 14 times 2.02, hit the equal button and divide by 18.02. The number that I get on the calculator is this 1.5711. If I round to 3 significant digits, I get 1.57, and that's grams of hydrogen gas, just like that. And I am done with number 4. Let's look at number 5. Number 5 says this: how many grams of silver will be formed from 122.6 grams of magnesium? I've balanced the reaction for you. It's 1, 2, 2, 1. Now let's start with what we know. So we're going to circle this right here. That's the number, and I'm looking for grams of silver. So start with the 22.6 grams of magnesium and divide by 1 times whatever unit goes on upper left goes in the lower right. These two units are going to cancel, and I'm going to be left with moles of magnesium. The 24.3 came right off of the periodic table. Now what I'm going to do is a multimole bridge. Upper left, lower right. That happens every time. They will cancel. I'm looking for the relationship between moles of silver and moles of magnesium. That relationship is right there. 1 mole of magnesium is going to produce 2 moles of silver. So it's a 2 to 1 mole to mole relationship, and now I'm in moles of silver. I've got one more step now. We're looking for grams of silver. So I'm going to put this unit, which is on the upper left, right here on the lower right. And I'm going to be left with grams of silver. So 100, that's going to be 107.87. 107.87 grams of silver is the mass of 1 mole of silver. And now I've got the right unit. I'm looking for grams of silver. So now it's just a matter of getting my calculator. 22.6 times 2 times 107.87. Hit the equal button. Divide that by 24.31. Here's what I get on my calculator, 200.56. But I'm going to want it to 3 significant digits because the 22.6 is the least of all these products and quotients, and it has 3 significant digits. 201 then will be my final answer. And last problem, number 6. Number 6 says iron reacts with chlorine gas to form iron 3 chloride. How many grams of iron 3 chloride are formed from 104.2 grams of iron? We're going to first write the balanced reaction. So here it is. The balanced reaction is, again, iron, that's solid, plus chlorine, that's gas, yields FeCl3, that's solid. It is a 2 to 3 to 2 relationship. 2 moles of this plus 3 moles of this yield 2 moles of this. So now that said, we've got the balanced reaction. We need to go back and find out what they're giving me. They're giving me this, 104.2 grams, and they're asking me for this. How many grams of iron 3 chloride are there? So start with the 104.2 grams of iron, put that over 1. Whatever unit's in the upper left goes into the lower right. That's automatic. These two will cancel. Remember, if I've got grams of anything, I'm going to have to convert that to moles. So I've done that. From the periodic table, 1 mole is 55.85 grams. So now I'm left with moles of iron. What's on the upper left is in the lower right. So I'm going to cancel this with this, and I'm left with, on top, moles of iron 3 chloride, because I'm going to do a mole to mole bridge right here. 2 moles of iron become 2 moles of FeCl3. So it's a 2 to 2 relationship. These two will cancel, but I still had to do that step. We've got moles of FeCl3 right here. And now what I'm going to do is I'm going to go to grams of FeCl3 because that's what I'm being asked for. So here we go. We've got moles of FeCl3 on top, so moles of FeCl3 on bottom. These two are going to cancel. And now when I add up iron with 3 chlorines, I get 162.20 grams. So now what I'm going to do is get my calculator. I've got 104.2 times 162.20, hit the equal button, divide by 55.85. That gives me 302.618 on my calculator. I only want 4 significant digits, so I'll round that to 302.6, and that will do it for that problem. Folks, on the next section, we're going to be looking at slightly more complicated problems. I'll see you on the next one. Thanks. Bye-bye.